Okay. Hello, ladies and gents. I'm going to be gone for various reasons. We can talk about it later. But I wanted to give you a little bit of help for today's activity, tomorrow's activity. So I'm going to give you a series of practice problems that you're going to work through. And so I want to give you some help on the first one, or one that's very similar to it. Let's say that you have a decedent that you find with a core body temperature of 79.6 degrees Fahrenheit. What is the PMI for this individual? So I'm going to walk you through how to solve these problems, and then based on this, you should be able to answer all of the other questions that I've got for you. It's only like 4 with multiple parts, but you'll be fine. So the way that we do this is we have to calculate how much heat this person's body lost. Now, hopefully you remember what the average human body temperature is, and that is 98.6 degrees. My arm's doing weird things. 98.6 degrees Fahrenheit. So at time 0, right when this person died, their average body temperature was probably 98.6 degrees. So how do we figure out what the difference is between the heat that they're at now, or the core temperature they're at now, versus where they were in the beginning? Subtraction. So we take 98.6 degrees Fahrenheit, and we subtract our 79.6 degrees Fahrenheit, and that gives us 19 degrees Fahrenheit, and that is heat lost. So they lost 19 degrees Fahrenheit. Now, when we think about heat loss in Algor Mortis, we think of it as like a 2-stage process. For the first 12 hours, this person is going to lose 1.4 degrees Fahrenheit every hour. After 12 hours, it cools down more slowly, so it's 0.7 degrees Fahrenheit per hour after that, until the person gets, or their body gets, to ambient room temperature. So we know for the first 12 hours, it's going to go down by 1.4 degrees. So I think the best way to start with this is we need to determine how much heat would be lost if the person was dead for the full 12 hours. So the way we do that is we take our 12 hours times our 1.4 degrees Fahrenheit lost per hour. And if we do 12 times 1.4, that gives us 16.8. And our hours and hours cancel. And that's going to be 16.8 degrees Fahrenheit. So that means at the 12-hour mark, a body would have lost 16.8 degrees Fahrenheit. Now, that value is important. It's a value we should probably remember for the rest of the unit. So we know that if a person lost more than 16.8 degrees Fahrenheit, they've been dead for longer than 12 hours. If it is less than 16.8, then they're somewhere over here. If the person lost less than 16.8 degrees Fahrenheit, then we can divide that value, whatever their heat loss is, by 1.4, and that'll tell us how many hours they've been dead. But since they are cooler than that, they lost more heat than that, that means that they died somewhere over here on this end of the timeline past 12 hours. So we have to figure out how far past the 12-hour mark they went. So we have to see how much cooler they are than 16.8 degrees. So we do another subtraction. Can you guys see that? We subtract the 16.8 from 19, and that's going to tell us how much more heat they lost. 2.2. 2.2 degrees Fahrenheit more in this zone. So remember how I told you if they cooled less than 16.8 degrees, we just divide it by 1.4, and it tells us how many hours they were dead in this zone. We're going to do the same thing over here for this new value, the 2.2 past that they are. So we're going to take 2.2 degrees Fahrenheit, and we're going to divide it by our 0.7 degrees, 0.7 degrees Fahrenheit per hour. And I'm just going to rough estimate this because I realized that my calculator is on my cell phone that I'm using to record this, and I'm not going to go do that. It's going to be 3 and change. So 3 times 0.7 is 2.1. So that's going to leave us with an additional 1 with a 0. So let's just call it, what, 3.1? We just call it that? Cool, 3.1. So our degrees Fahrenheit cancels, leaving us just with the unit hour. So this is going to be approximately 3.1 hours. Now, you're like, cool, the person's been dead for 3.1 hours. No, they've been dead for 3.1 hours in this zone, plus the full 12 hours that they had to go through to get to this zone. So therefore, 12 hours plus that 3.1 hours is going to give us approximately 15.1 hours as our PMI. I like to put my final answers in a rectangle because my eyes see the right angles more easily. So that would be the answer to this question, is 15.1 hours would be the PMI. Now you can use the PMI to find the TOD. If you know that this person's been dead for approximately 15 hours, you should be able to take a look at what we learned about with regard to rigor mortis in the timeline. Notice how we used a 36-hour scale to kind of remind you that rigor mortis happens in a 36-hour frequency. Well, not frequency, like the whole lifetime of the rigor mortis situation is 36 hours. But I'm trying to remind you of that in a subtle way. So you should be able to tell me whereabouts in rigor mortis this person would be if they've been dead for 15.1 hours, because remember, they go into full rigor at 12. They're completely back out of rigor at 36. So you should be able to tell me where they are with respect to rigor. They should be starting to come out of rigor at this point, but how far into it? So the way that I like to think of it, if we have a little timeline, is, remember, this is the 0 time, it's gonna go all the way to 36, so this is gonna be a little baby timeline. So it starts at about 2 hours, right? That's when it starts. They're in full rigor at 12. They're completely out of rigor at 36, which means at the 24-hour mark, they should be about halfway out. So if we think about a little stick figure, we do a little circle, right? There's a little person. This is horrible, oh my God. So I didn't tell you guys, I got an art scholarship for sculpting, obviously not for drawing. If we think about rigor as being something that I'm going to color in with these little green markers here, so the person would start to go into rigor, so we just see it starting in their head. Looks like he's wearing a little army cap. At the 2-hour mark, we said at 12 hours they would be completely in rigor, so everything would be highlighted and covered. At the 24-hour mark, they should be about halfway done with rigor, which means from the waist down would be highlighted, and then at 36 hours, they're completely out. So that means they'd be halfway into rigor at the 6-hour mark, and then you can kind of see incrementally how they fade back out. So with this very rough estimation, I think you should be able to give me sort of a timeline on whereabouts they'd be at the 15-hour mark. You have like 4 questions that are like this. I am fully confident in your abilities. Please make sure you turn in by the end of the day, hopefully by the end of the hour, okay? Yeah, let's just call it the end of the hour. You should be able to do this by the end of the hour. So please make sure you hop on Canvas. Actually, you're already on Canvas, so you wouldn't have seen this. So yeah, good luck. Happy Halloween. See you later.